Hi, my name is Venkat Ganesh. In this video, I will walking you through a containerized real-time object detection service I recently built. The goal of this project was to deploy a state-of-art computer vision model into robust backend architecture complete with a web interface. For the backend, I used Fast API, and for frontend, I used Streamlight. The problem solved and use case this architecture solves the challenge of safely deploying heavy machine learning models into scalable backend. A real-world use case for this exact setup would be an automated security camera feed or real analytics where a central server needs to process images from multiple store cameras concurrently. Coming to the high-level flow, this architecture consists of two isolated microservices, an API and an UI. The user interacts with the Streamlight UI that is running on the port 8501, where the backend API will be running on the port number 858000. Why this approach is selected means I choose FastAPI because it is extremely fast and handles asynchronous requests well, which is perfect for for ML workloads. I kept the UI and API separate containers to follow microservice best practices, allowing the backend to the scalable independency of the frontend. Coming to the code walkthrough, let me show you one by one. First one is API, which is used to run the backend, and the main logic will be contained in the main.py, where it takes the model from the downloaded models folder and it will check whether the model is correct or not, and it contains a health check, and the main thing is detect endpoint. It contains the detect logic from the image we given. And next one is models. It contains the model we have downloaded, and output will contain the last annotated output, and script is used to download the model. And final UI, it is used to build the web interface, which is Streamlit. And last one is Docker Compose, which is used to write the instructions to run the project with Docker. Let's go deep dive with the project. First, let us run the project using command docker compose app build. Here you can see the error is solved due to internet issue and the project is running successfully. Let us test the application. Here you can see the browser interface is running on the 8501 port. Here we have to drop a image to test the object detection model, that is Yolo V8. I have taken a sample image which contains a laptop, book and some papers or pens. I am giving this image to this model. Now this is the original image, and I am clicking detect objects button. Here you can see the detection is completed and it has identified two objects correctly. That is first one laptop with confidence level 0.98 and second one is book with confidence level 0.47. This is the way it can detect the objects, and this is the JSON detection summary, and this is the raw detections. And let's do an experiment by decreasing the confidence threshold to minimum, and I am clicking the detect objects. You can see it is detecting a pen object, but uh, the name is not identifiable, and the papers as book, and the keyword is also detected when the confidence is with confidence level 0.14. This is the way it can be used the confidence threshold. And coming to the limitations of this project, currently the API only accepts the .jpg and .png images, and the future scope of the project is I would improve this by adding support for real-time video streaming via WebSockets, and I would also integrate a message broker like Redis or RabbitMQ so that it thousands of requests come at once they are placed in queue rather than overwhelming the server's RAM.